Hey guys, welcome back to Iron Math. Today I'm going to teach you a little bit about exponent rules. This is part 1. These are the very basics of them. So, let's get right into it. So, the first thing we need to know is this is a regular, exponent, x cubed. So, what we need to know, this x is called the base, and this 3 up here is the exponent or the power. So, now that we know this, remember to keep those terms in your head. So, let's say I give you x cubed times x squared. Okay. Well, the first thing I notice is that the bases are the same. Okay, so right now what I'm going to do is that I'm just going to expand this. So x cubed is just the same thing as x times x times x, and x squared is the same thing as x times x. So now, how many x's do I have? I have 1, 2, 3, 4, 5. So I'm multiplying x 5 times, and I get x to the 5th. Okay, so this is our first question, but let's see if I can show you guys a pattern. Let's say I give you x to the 4th times x squared. So again, I'm going to expand this, x times x times x times x, and expand this as well, x times x. Okay, so now I have 1, 2, 3, 4, 5, 6. So I'm multiplying x 6 times, x to the 6th. Okay, so I don't know if you guys notice a pattern, but if you guys can see, if we look at the exponent, and then we look at our answer, we can see all we've done is just add the exponents. And the same thing down here. We look at the exponent, and we look at our answer, and what we see, we've just added 4 plus 2 is 6, and 3 plus 2 is 5. So, this is a really important part of exponent rules. When you multiply two exponents that have the same base, you just add the powers together. So, for example, if I give x to the 7th times x to the 11, I know that these x's are the same base. So all I have to do now, I just have to add the powers. So 7 plus 11 is 18, and that's my answer. But one thing you have to be careful for, if I say x to the 6th times, let's say y to the 7th, I can't say xy to the 13th, because x and y are two different bases. They're two different variables, so I can't add these exponents. Now let's move on to division. Let's say I give x to the 5th over x cubed. Well, now I'm going to expand this again. X times x times x times x, and one more x, divided by x cubed, so x times x times x. Okay, so now I'm just going to cancel these x's, and now I'm left with two x's on the top, and that gives me x times x is just x squared. Okay, so we have x squared for our first answer. Let's say I give us x to the 7th. Actually, I'll give a smaller number. X to the 4th over x squared. Well, x times x times x times x over x times x. So now, once again, I'm going to cancel. I'm left again with x squared. Okay, so if you guys see a pattern, once again, these x's are the same base in both equations I gave. And we got x squared for both. So now, as you guys can see, all we did, we just subtracted the powers. We just did 5 minus 3 and 4 minus 2. Right? And that gave us our x squared. So then, if I give us x to the 7th over x to the 5th, or no, I'll give it like x to the 3rd. I see these are the same base. And now, all I have to do, I just have to subtract these powers. That's it. I don't have to write 7 x's on the top, 3 x's on the bottom, and cancel everything out. No, I can just write 7 minus 3 is 4, and that's my answer. So this makes it a lot easier for you guys to solve these kind of questions really quickly. And if they give you something like x to the 100th over x to the 50, what would this be? Well, no one's going to want to write out 100 x's and then 50 x's on the bottom. Right? All you have to do is just 100 minus 50 is 50. So that's my answer. So when you have two bases, two of the same bases divided by each other, all you have to do is subtract the powers. Okay, this one is kind of like a crazy one, but let's say I give you x to the 0. What would this be? Well, a lot of people are going to say, oh, x to the 0 is just 0. Well, it's actually 1. So to find out why this is, let's say x is 2. Okay, x equals 2. So I have 2 to the 1 is 2. 2 squared is 4. 2 cubed is 8. 2 to the 4th is 16. Right? So we have this pattern. Okay? Every time we go down an exponent, we divide by 2. Right? We divide by 2. Divide by 2. Divide by 2. So now, when we have 2 to the 0, this pattern still continues. We're going to divide by 2, and 2 divided by 2 is just 1. And this works for anything. You can put in 3. You can put in a million, right? So anything to the 0 equals 1. 500 trillion is to the 0 power is 1. A tiger to the 0 power is 1. Whatever you put into x to the 0, it's going to equal 1. And that's because every time you reduce your exponent by -1, you divide, right? So we can see to the 4th divided by 2, divided by 2, divided by 2, divided by 2, and you get to the 0 is 1. And so you can do this if you want to try to prove it yourself. You can put in, let's say, 3, and you can see that when you hit 3 to the 0, you're also going to get 1. So if I give you 1, I don't even know what this number is going to be, to the 0, what's this going to be? This is going to be 1. Doesn't matter how big this number is. This is 100 million. To the 0, it's 1. It's always going to be 1. And this is an important rule because a lot of people try to trick you with this on your exams. So let's move on to the next one. Let's say we have something like this. X cubed squared. So we have x cubed in parentheses and all of that is squared. Okay, so let me try to simplify this down. So I have x cubed times x cubed. This is all this means, right? And we've learned from our previous rules that we have the same base, we just add the exponents. So it's x to the 6th. Okay, let's try x to the 5th cubed. Okay, so we have x to the 5th. I'm just going to expand this out. X to the 5th times x to the 5th. Okay, again, we have all the same bases, and we know we can add the powers. So 5 plus 5 is 10, and plus another 5 is 15, right? So 5 plus 5 plus 5 is 15, and that's my answer. If you guys see a pattern, when you're raising another exponent to a power, all you have to do, you multiply. You multiply, right? So this is just x to the 3 times 2, which is x to the 6th. This one is x to the 5 times 3, which is x to the 15th. But don't get this confused with something like x cubed times x cubed. This only works because you're raising this whole x to the 5th to the 3rd power. So let me give you, let's say I give x to the 7th to the 7th power. All of it to the 7th power. Well, using what we know, we have x to the 7 times 7, which gives me x to the 49th. And if we expand this, we can see that we're right. So these are all the basic exponent rules we need to know. There's another one on fractional exponents, but I won't get into that one today. But just as a recap, let's go over everything we've learned. Okay, so here's our recap. So of all the rules we've learned so far, so we've gotten x to the m. So these are any numbers. X to the m times x to the n is x to the m plus n, right? Same bases, you add the exponents when you're multiplying. Next one, the most recent one we did, x to the m to the n. When you raise an exponent to another power, you're going to multiply x to the m times n, right? We did this and we proved it. So let's say I give you x to the m over x to the n. Again, we're dividing these exponents, so, and they're the same base. you have x to the m minus n, right? Because these cancel. But we don't want to keep writing all these numbers out. We just want to do this just like that. And x to the 0 equals 1. Okay? So x to the 0 equals 1, and we get x to the 0 equals 1. So anything to the 0 equals 1. A million, a trillion, 5 billion, 5, 7, anything equals 1. And we proved it by the dividing. So I hope you guys enjoyed this video. If you liked it, please leave a comment on what I should do next. And I'll see you guys in the next one. Thank you so much for watching.